Good morning, students, my brothers and sisters, wherever you are in this world. Today we are learning a calculation involving molarity. So this is very important concept, calculation involving molarity. Molarity can also be called concentration in moles per liter. If you are told calculate molarity or concentration in moles per liter, then it's the same way with molarity. Concentration in moles per liter, and also calculate the molarity, it's the same. We also call molar concentration. So when you want to calculate such questions about concentration, let us see this example. Our last lesson, lesson 18, we have learned how to calculate concentration in gram per liter. But this one is totally different. This is question or lesson 19. This is lesson 19. In this lesson, we are learning molarity. Calculate the concentration in moles per liter of the following. Now we have 4 gram of sodium hydroxide solution containing 500 centimeter cubic of solution, where sodium we have 23, hydrogen 1, oxygen 16 in the bracket. So let us start solving the equation of solution. Let us start solving So in this equation, we have first, before we start now to get molarity, we need to get concentration. We have to get concentration. When we get the concentration, that's the time we can get the molarity, because molarity can be obtained. Molarity is equal to, this is the formula that you use molarity, over molar mass. So this is the formula that we can use to calculate concentration. To calculate molarity. Molarity can be obtained concentration gram per liter over molar mass. Now, for you to get now molarity, we need to have these two, molar mass and also the same way concentration in gram per liter. How do you get concentration gram per liter? Then this is how you get it. First, we have to get concentration gram per liter. This is how we get it. Okay, 4 gram is equal to 4 gram of sodium hydroxide is equal to 500 centimeter cubic. 500 centimeter cubic. This is the volume of the water or the liquid that we have dissolved with 4 gram of sodium hydroxide. Then to get concentration is equal to 1000. Concentration gram per liter is equal to 1000. Okay, is equal to 1000. Cross multiplication. This is lesson 18 that we have learned. You can revert back lesson 18 how to get concentration. Okay. Now here we have. Let me move my screen a little bit down. Let me move my screen down. Yes. Then we have 4 gram is equal to 500. Then 1000 centimeter cubic. How much will it be equal? Then you will say 4 gram times 1000 centimeter cubic all over we multiply 4 and 1000 all over 500 centimeter cubic. So we need to do cancel it. We need to cancel it. The unit is like centimeter cubic and centimeter cubic, they cancel. 20 and 20 they cancel it. We have 5 and 10 here. By 5, 1. By 5 we have 2. 2 times 5, 2 times 4, then the result will be 2 times 4, the result will be 8 gram per liter. Now our target is not only 8 gram, our target is we need to get the molarity. We need to get the molarity, because the question is asking calculate the molarity. That's what the question is saying. Calculate the molarity. Yeah, that's the question. Let me go up and show you. The question is saying calculate concentration in moles per liter, which means the molarity. Another name of concentration in moles per liter is also called molarity. Okay, how do you get the molarity? This is what we do to get the molarity. Molarity can be obtained concentrating gram per liter over molar mass. Now let us get the molar mass. Molar mass of this sodium, the molar mass of sodium hydroxide. How do you get the molar mass of sodium hydroxide? Sodium in the bracket we have 23 plus oxygen, one oxygen we have in the bracket 16 plus hydrogen, one hydrogen in the bracket we have 1. Then in total we have 40. Therefore molarity is equal to concentration in gram per liter that we have obtained 8 gram per liter over RFM, which is 40. Then when we divide 8 divided by 40, this is what we get. 8 divided by 40, this is what we get. Use the calculator please to calculate that. 8 divided by 40, very simple, 0.2. You'll get it, 0.2 molar. So when you want to write that, you'll write 0.2 molar. 0.2 molar of sodium hydroxide. M, the capital M shows the molarity. Capital M shows molarity. So let us also do question Roman 2. Part B the same way. It's asking 10 gram of calcium carbonate containing 250 centimeter cube of solution. Okay, first we have to calculate concentration. How do you calculate the concentration in gram per liter? We will say 10 gram is equal to 250 centimeter cubic. Then we will say 1000 centimeter cubic. How much will it be equal to? X, we don't know, cross multiplication. Then what do you get? 10 gram times, you multiply 100, 1000 centimeter cubic all over 1000, over 250, all over 250 centimeter cubic. What I'm doing here is I'm multiplying 10 times 1000, then anything you multiply x, it goes down. It goes down. Now in this section we have divide it by using let's do cancellation first before we divide it. So we cancel centimeter cubic and centimeter cubic, 1 0 and 1 0. Then by 5 here, 5 by 5 is 5. Then by 5 here is 2. 10 divided by 5, the result is 2. Okay, by 5 we do 1, and 100 divided by 5 is 20. Then 20 times 4, the result is 20 times 4, the result is 40 gram. The result is 40 gram per liter. Now, since the result is 40 gram per liter, then we can calculate. Still, we are under B, so we can calculate the concentration or molarity. Okay, molarity can be obtained. Molarity is equal to concentration in gram per liter over RFM. Now to get concentration in gram per liter, we have already obtained concentration in gram per liter as 40 gram per liter, but what we are looking is molar mass or RFM. Molar mass or RFM or molar mass is the same. For you to get RFM or molar mass of calcium carbonate. So what do we have the value of calcium? We can go up and check it in the bracket. In the bracket, calcium is 40, carbon is 12, oxygen is 16. So let us do it. Calcium 40 plus carbon 12 plus oxygen 16. 116 times 3. Then here you get it 40 plus 12 plus 16 times 3 is 48. So when you add all of them, this is plus. When you add all of them, you'll get 100. You'll get 100. So that 100, you'll get 100. Therefore, molarity is equal to concentration gram per liter, which is 40 gram per liter. Why my pen is not going well? Let me do that erasing. Okay, we have 40 gram per liter for concentration over RFM, which is 100. Then when you divide, this is what you get. Then when you divide, this is what you get. You cancel this one, sorry. When you divide, this is what you get. You cancel 0 and 0. Then here you have by 2, 2, by 2, 5. So when you divide 2 by 5, then what do you get? What do you get? 2 divided by 5, obviously, that's a simple fraction. 2 divided by 5 is 0.4. The answer is 0.4. The answer is 0.4 molar of calcium carbonate. That's the molarity of calcium carbonate. Yes, guys, if I summarize now, the question, when you are told to calculate concentration in moles per liter, this is what you do. First, you have to get concentration gram per liter by equating the mass and the total volume. Then what about 1000? When you get now concentration in gram per liter, then you use that formula. Concentration is equal to, you use this formula. Concentration, molarity is equal to concentration gram per liter over molar mass, or RFM. You use this formula. Then, but the first thing is you have to get the concentration in gram per liter by equating the mass and the total volume. What about 1000? When you get the concentration gram per liter as 8 gram per liter, then you have to calculate the molar mass of the compound, which we have learned in the previous lesson. Then when you get that molar mass, then you divide it. Then from there you get the molarity. Molarity, the symbol that you give is always capital M. Capital M. I hope you have understood it. For further question, you can write in the comment section. If you have any question, please subscribe and share my YouTube channel, eLearning Academic 2030. That is my YouTube channel. Please subscribe and share so that you will understand and any problem that you have in the future. Thank you.